Classroom TV.
Good day, class. Welcome back to Chemistry with Organic Chemistry course. So for today's lesson, I'm going to discuss the chapter 6, which is Chemical Reaction and Equation. So after this video, the viewers are expected to define chemical reaction, identify the signs of chemical reaction, formulate on how to write chemical reactions, apply balancing, classify the type of chemical reaction, and determine if temperature affects chemical reaction. Chemical reaction is a process that leads to the transformation of one set of chemical substances to another. Classically, chemical reaction encompasses changes that only involve the positions of the electrons in the forming and breaking of chemical bonds between atoms, with no change to the nuclei, and can often be described by a chemical equation. So chemical reaction can be found and observed in many things, like cooking and in respiration, roasting, and formation of curd, in changes in color and evolution of gas, change in temperature, and formation of precipitation. All of these scenarios are happened with a process called chemical reaction. So when the chemical is changed, the chemical equation will also change, and it's very important to know by everyone. So chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formula. For example, magnesium plus oxygen will form magnesium oxide. So the product of the reactant magnesium and oxygen is magnesium oxide. The substances that undergo chemical change in the reaction is the magnesium and oxygen, and they are called reactant, while the new substance formed during the reaction is magnesium oxide, and it is called the product. So chemical reaction always involve reactant and the product. A word equation show change of reactants to product through an arrow placed between them. So this is the example of an equation. The reactants are written on the left side. This is the reactant, the sodium plus chlorine. Then the products are written on the right side. So the arrowhead points towards the products and show the direction of the reaction. So now this is the reactant, and when sodium and chlorine combine, it will form a product of sodium chloride or table salt. So what is a skeletal equation? Skeletal equation are those equations which shows the reactant and the product so formed without balancing them. So this example, or the example of a skeletal equation, is magnesium and oxygen, or magnesium plus oxygen, and this is the reactant. So the product of magnesium and oxygen is magnesium oxide. So it means that skeletal equation is the formation of two reactants to form a product without balancing. It is also known as unbalanced equation. So what is balanced chemical equation? So a balanced chemical equation occurs when number of the different atom of elements in the reactant side is equal to the product side. So this is the reactant, magnesium plus oxygen, and then the product is magnesium oxide. But this time, we need to balance the reactant to product. So if you see in this reactant, the oxygen here has 2 atoms written in a subscript. And then in the product, to balance the equation, we need to add 2 in the coefficient to balance this. So what are the steps in balancing an equation? So this is a reaction between methane and oxygen, producing carbon dioxide and water. So in this example, the reactants are this, and the products are this. So the reaction shown is a combustion reaction. A compound reacts with oxygen and produces carbon dioxide and water. The technique is to balance the carbon atoms first, then the hydrogen atoms, and then the oxygen atoms. So to easily known or recognize if the atoms of the products are balanced to the atoms of the reactants, the simple way is to list down the element and the number of atoms. So we need to list down the element carbon, hydrogen, and oxygen. Then we need to write down the number of atoms. So in this reactant, the carbon is 1, the hydrogen is 4, the oxygen is 2, and in the products, the carbon is 1, the hydrogen is 2, and the oxygen is 3. So we can notice that the carbon in the product and the carbon in the reactant are the same. So we can see here that the carbon of the product and carbon of the reactant have both 1 atom. In this case, the carbon atoms are already balanced. So now we look at the hydrogen atoms. So there are 4 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side. To balance them, we put a coefficient of 2 before H2O. So 2 times 2 is equal to 4. Now the hydrogen atoms are balanced. Due to the coefficient 2, in front of H2O, there are 4 total oxygen atoms on the product side. So to balance the oxygen atoms on both sides, we need to put a coefficient of 2 in front of O2 in the reactant side. So 2 times 2 is equal to 4. So now the oxygen in both our reactants and product are balanced. So next is, what is physical state? The physical states of the reactants and products are mentioned along their chemical formula. The gaseous, liquid, aqueous, and solid state of the reactants and product are represented by the notation G, L, AQ, and S respectively. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. are indicated above or below the arrow in the equation. So this is the equation of photosynthesis. So the reactant here, or the reactants here, are carbon dioxide and water. So to produce glucose and oxygen, sunlight must needed. Okay, then let's proceed to the types of chemical reactions. So there are several types of chemical reaction: the combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and the oxidation and reduction reaction or redox reaction. First is a combination reaction. In combination reaction, two or more substances combine to form a new substance. In this example, the reactants here are carbon and oxygen. Carbon, which is solid, and oxygen, which is gaseous, are combined to form carbon dioxide, which is gaseous. Then next, hydrogen and oxygen are combined to form water. Now let's proceed to decomposition reaction. In a decomposition reaction, a single compound breaks down to produce two or more similar substances. The composition reaction takes place when energy is supplied in the form of heat, electricity, or light. So the first kind of decomposition reaction is electrolysis. When a substance is decomposed by passing electric current, the process is called electrolysis. So in this equation, the reactant here is water. So water will break down to produce hydrogen and oxygen. The other kind is thermal decomposition. It is a process when a substance decomposes on heating. So in this example, the reactant is calcium carbonate, and when calcium carbonate exposed to heat, it produces calcium oxide and carbon dioxide. The other one is the decomposition that involves sunlight, and it is called photochemical decomposition. The example for this is the separation of silver bromide. So this is the silver bromide. Silver bromide is a soft, pale yellow, water-insoluble salt well known for unusual sensitivity to light. When silver bromide exposes to sunlight, it breaks down and produces silver and bromine. So before we proceed to the next type of reactions, I have here the reactivity series of metals. A reactivity series is an empirical calculated and structurally analytical progression of a series of metals, arranged by their reactivity from highest to lowest. It is used to summarize information about the reaction of metals with acid and water, single displacement reactions, and the extraction of metals from their ores. So in this graph or in this table, potassium to lead are the metals that more reactive than hydrogen. Potassium to calcium reacts with water, while the magnesium to lead reacts with acid, while the metals antimony to platinum are less reactive than hydrogen. So next reaction is the displacement reaction. In a displacement reaction, a more reactive metal displaces or removes another element from a compound. In this reaction, zinc is more reactive than copper. So zinc displaces copper from copper sulfate. Then the double displacement reaction, this is the reaction in which two different atoms or group of atoms are displaced by other atoms or group of atoms. So next reaction is the precipitation reaction. It is occurs when cations and anions in aqueous solution combine to form an insoluble ionic solid called precipitate. It is refers to the formation of an insoluble salt when two solutions containing soluble salts are combined. So this time, when silver nitrate, which is soluble, and sodium chloride, which is soluble too, combine, will produce silver chloride that are not soluble and sodium nitrate that are soluble. So the solid precipitate is silver chloride. This is insoluble that produce when silver chloride or sodium chloride and silver nitrate combine. Next is the neutralization reaction. Neutralization reaction is a type of double replacement reaction. In this reaction, hydrogen and hydroxide combine to form hydrogen hydroxide or water. A salt is a product of an acid-base reaction. So in this reaction, hydrochloric acid or HCl is the acid and sodium chloride or NaOH is the base. When these two combine or undergo neutralization reaction, it will produce NaCl and water. So for a brief recap, there are 5 types of chemical reaction: the combustion, combination, decomposition, double displacement, and displacement. Now let's proceed to exothermic reaction. An exothermic reaction is a chemical reaction that releases energy by light or heat. It is the opposite of endothermic reaction that I'm going to discuss in the succeeding slides. It is expressed in the chemical equation reactants, arrow, products, plus energy. So now let's explore the exothermic reaction occurring around us. The good example of exothermic reaction is the cellular respiration. Cellular respiration is an essential exothermic reaction that occurs in every cell and provides energy to our body to maintain all the vital function of our body. The sugar molecules of our body breaks down into carbon dioxide and water molecules, plus they release energy. The energy released during the breakdown of sugars is used in the synthesis of ATP, which is the energy carrier molecules of the cell. The other one is the formation of ice cube. When water freezes into ice cubes, the energy is released in the form of heat. When water molecules begin to freeze, their particles come close and forms a new bond. As in exothermic reaction, the energy released is more when new bonds are formed than the energy required when bonds break. So ice cube formation is an exothermic process. Then the last example is the burning of candles. The candle is a paraffin wax which is made up of hydrocarbons. When the candle burns, it comes in the contact of oxygen and there is a breaking of hydrocarbon bonds and hence the release of energy takes place. That's why it feels warm around the burning candle. Now let's proceed to endothermic reaction. Endothermic reaction requires or take in energy in order for it to proceed. This required energy can be provided in many forms, but it is typically in the form of heat. Example of endothermic reaction is the photosynthesis, because sunlight are needed or need to apply to carbon dioxide and water to produce glucose and oxygen. So another example of endothermic reaction is the dissolving salt in water, the water evaporation, the baking of bread, and the cooking of egg. So to summarize this, exothermic reaction releases heat, causing the temperature of immediate surrounding to rise, while an endothermic reaction absorbs heat and cools the surrounding. So again, exothermic releases heat, and then endothermic absorbs heat. Okay, so now let's proceed to oxidation and reduction reaction or redox reaction. Oxidation is addition of oxygen and removal of hydrogen. Any chemical substances following any this is said to be oxidized. Then reduction is the removal of oxygen and addition of hydrogen. Any chemical substances following any of these rules is said to be reduced. So oxidation and reduction reaction. It is a reaction involving both oxidation and reduction process occurring simultaneously are known as redox reaction or oxidation and reduction reaction. For example, in the extraction of iron from its ore, an oxidizing agent gives away the oxygen to another substance. In this example, iron oxide is the oxidizing agent. Then, the reducing agent removes oxygen from another substance. In other words, it takes in oxygen. In this example, the reducing agent is the carbon monoxide. Because both reduction and oxidation are going on the same time, this is known as redox reaction. So oxidation and reduction in terms of electrons transfer, oxidation is loss of electron, while reduction is gain of electron. Okay, so now let's proceed to the effects of oxidation reaction in everyday life. Number 1, corrosion. Corrosion of iron is called rusting, and it is a serious problem. Every year, there is an enormous amount of money is spent to replace and damage iron. Galvanization is a method of protecting steel and iron from rusting by coating them with thin layer of zinc. Second is rancidity. Rancidity is the most important cause of deterioration in fats and fatty foods in oxidation. Rancidification, the product of which can be described as rancidity, is the process which causes a substance to become rancid, that is, having rank, unpleasant smell or taste. So before I end this presentation, I want you all to familiarize the difference between chemical reactions and nuclear reactions. Some of these are the chemical reactions involve some loss, gain, or overlap of outer orbital electrons of the reactant atoms, while nuclear reaction involve emission of alpha, beta, and gamma particles from the nucleus. The chemical reaction is balanced in terms of mass only, while the nuclear reaction is balanced in terms of both mass and energy. So thank you very much for watching and listening. I hope you just learned something today. Have a good day.